A rational equation is one where we have at least one x in the denominator of one of the fractions, and so this one is definitely rational. And in order to solve a rational equation, the first thing that we want to do is to clear the fractions by multiplying both sides of the equation by the LCD. And the LCD is, of course, the least common denominator. In order to determine the least common denominator, first we have to factor each of the denominators in all of the fractions. And so that's where we're going to begin. So our first fraction becomes x over, and we can factor out the 2 from the denominator to get x plus 1 that remains. The next fraction we have is 2x minus 3 over. X plus 1 is a linear denominator, which doesn't factor anymore. And then from that, we're going to subtract 2x over. We do have a common 4 in this next denominator, so we'll factor out that common 4. And now all of the denominators have been completely factored. The LCD is going to be the smallest quantity that all of the factors divide evenly into. We can determine that LCD by ensuring that it contains all the factors of each of these denominators. So we're just going to begin with the leftmost denominator and pick up all the factors of it. So in order for the first denominator to divide evenly into our LCD needs to contain its factors. Then we move to the next denominator and say, well, does our LCD contain its factors? And since we already have an x plus 1, yes, it does. So that second denominator is going to divide evenly into it. Then we move over to our third denominator, and we want to make sure that this denominator divides evenly into the LCD. We do have the factor of x plus 1, but we don't have the entire factor of 4, so we're going to need to pick up another factor of 2 to ensure that our third denominator divides evenly into the LCD as well. Multiplying all this together, we get 4 times x plus 1, which is now the LCD, meaning it's the smallest quantity that all 3 of the denominators will divide evenly into. Now, as we said a moment ago, the idea is to clear the fractions, and we do that by multiplying both sides of this equation by this least common denominator quantity. So because we have an equation, we can multiply both sides of an equation by anything that we want. So long as we do the exact same thing to both sides, we will still have equality, we'll still have a balanced equation. And so what we're going to choose to multiply both sides by is this LCD over 1. So first we'll multiply the LCD by the first quantity over on the left, so we'll just copy paste x over 2 times x plus 1, and that's going to be multiplied by the LCD, 4 times x plus 1, over 1, which is then going to be equal to the LCD now times this next term, so we have 2x minus 3 over x plus 1, which is going to be multiplied by our LCD, 4 times x plus 1 over 1. And then from that we subtract the LCD now times this last term, so we have 2x over 4 times x plus 1, which is that last term, that is also then multiplied by this least common denominator, again over 1. From here, it's easier to see that when we multiply all of these terms by the least common denominator, all of the factors in each of these denominators are going to divide evenly into it. So the x plus 1's cancel out, 2 divides evenly into 4 and leaves a factor of 2 that remains. The x plus 1's cancel here, and we have a factor of 4 that remains. The x plus 1's cancel here, and the 4's cancel entirely here. So all of those terms in each of the denominators have canceled out. Now, we're supposed to solve the resulting equation. Let's take a cleanup step here because these products are pretty messy in their current state. So let's notice that what we have out of this first product over here on the left is the remaining factor of x times the remaining factor of 2, so we have 2x over here on the left. From the next product, we have the numerator 2x minus 3 multiplied by the remaining factor of 4, so let's just write that down. 4 times 2x minus 3 is all that remains out of this next term, minus the only thing that remains out of this last product is the 2x, so we'll just bring down that 2x. And now we can see that the resulting equation is just linear And we can use our linear strategies in order to solve it, which means that we're going to want to distribute this 4 into the parentheses first, combine like terms, and so on. So let's copy paste the left-hand side just to give us 2x, and then we have 8x after we distribute in that 4 minus 12 minus 2x. And now let's combine like terms, so 8x minus 2x is 6x. So left-hand side again is just still 2x, 8x minus 2x is 6x minus 12. And then from here we're going to want to get our variables to one side and our constants to the other. So let's subtract 6x from both sides. So the variable terms will cancel out. On the right, we'll have negative 4x on the left, and the negative 12 just gets copy-pasted down here on the right. And so the last thing that we need to do is divide both sides by negative 4, which yields that x is going to be equal to positive 3. And now in order to check this answer on our calculator, we'll take x is equal to 3 and then store that into the x quantity and hit enter on our calculator. And then we're going to take that quantity back to the very beginning and plug it in for each of the x values. We're going to plug it into the left-hand side and then see what the overall output is on the left, and then compare that to the overall output of the equation on the right with our 3 stored in for x. So let's begin with the left-hand side. We're going to want to get a numerator-denominator function, which can be found in one of two places. We can either hit alpha and then this button here to get that numerator-denominator, or we can hit alpha and then F1 right here, which brings up this menu, allowing me to access that numerator-denominator feature. And then we have this fraction that makes it easier for me to ensure that everything is in the top and bottom as it is supposed to be. So we have x over 2x plus 2, and again we just want to see what the left-hand side is equal to with our solution stored in for x, and then compare that with the right-hand side. So I'm going to hit, again, alpha F1 to get that numerator-denominator feature. Then we'll plug 2x minus 3 into the numerator, x plus 1 into the denominator. And then from that, we're going to subtract another fraction, so alpha F1 again, and then hit enter when my cursor is next to the numerator-denominator function. We have 2x in the top, 4x plus 4 in the bottom, and we just want to compare that to the output on the right, and both sides yield the same quantity on the left and the right with our solution stored in for x. So that tells us that our solution is correct.